So here was your warm-up today, and here are the answers to the warm-up to make sure that you guys understand. Here was the compound that you guys were supposed to copy down, HCl4. The elements that are present in this compound are hydrogen and chlorine. I can tell there's two different elements because there's two different capital letters, H for hydrogen, Cl for chlorine. The ratio of atoms within this compound is 1 to 4. That's because there's one hydrogen atom. If there's no subscript after the letter, then that indicates that there's only one of that atom. But chlorine has a subscript of 4, meaning there are 4 chlorine atoms. So 1 hydrogen atom to 4 chlorine atoms is the ratio. And if I were to draw the bubbles, it would look something like this. Yours doesn't have to be colored like mine, but you should have drawn one circle with an H representing the 1 hydrogen atom and 4 circles with a Cl inside representing the chlorine atoms. Now, a common mistake people make is that they draw a circle with a C inside and an L inside another circle. But since chlorine, Cl is 1 atom, the Cl should be inside of 1 bubble. So if you do not have 1 H bubble and 4 Cl bubbles, then you need to fix your picture. Also, just the reason why I drew the H smaller than the Cl atoms is because hydrogen is a smaller atom than chlorine. Hydrogen only has 1 proton and chlorine has more protons than that. Off the top of my head, I think it's 17, has 17 protons. And then question number 4, when does a chemical reaction occur? Well, a chemical reaction occurs when atoms bond together or they break apart, therefore forming new substances. For example, let's take if we had a water molecule, H2O, and the bonds between those atoms broke apart, we would have oxygen and 2 hydrogen atoms. Well, we would no longer have water. We would have an atom of oxygen, which is a gas, and 2 atoms of hydrogen, which are also flammable gases. And so if the bonds break apart, we have a brand new or 2 brand new substances, and therefore a chemical reaction has occurred because we've made something new. So today you're going to be taking some notes on chemical equations. Get your paper ready for today to take your notes. A chemical equation is just a short way of showing which compounds are involved in a reaction. So like if when you're typing or texting and you write LOL, obviously you're not going to type out all the words laugh out loud. You would just type LOL, which is a short way of writing out that you're laughing. But chemical equations are the same way. It's just a short way of showing which compounds are involved in the reaction. And when you're writing a chemical formula, it's kind of like a math equation, but it doesn't have an equal sign. And that is because carbon plus 2 atoms of oxygen would not make or not equal carbon dioxide. It's not the same thing. Instead, carbon plus 2 atoms of oxygen, if there was a chemical reaction, and it formed carbon dioxide, these 2 atoms make that. So the arrow in a chemical equation or chemical formula means makes or yields, because these 2 things are not equal to that. These 2 things make that. And so we would say that carbon plus oxygen makes carbon dioxide. Take a quick pause to write a question about these notes and write out this diagram or formula. The parts of a chemical equation. A reactant is the stuff present at the beginning of a chemical reaction. It's kind of like the ingredients, the things that are present at the beginning. So if I were to look at this chemical formula, N2 has 2 nitrogen atoms, 2O2, which means I have 2 oxygen atoms, but I have that 2 times. I have 2 molecules of oxygen. And if a chemical reaction happened and produced this, then this would be the product. A product is the stuff you get at the end of a reaction. It's the new stuff that gets produced. So I want you to write out this formula, circle and label the reactants, the stuff present at the beginning of the reaction, and please circle and label the product or the stuff present that's at the end of the reaction. And then write a question about these notes, the difference between a reactant and a product. Next, Here's another example of reactants versus products. I want you to have some practice in this. There are 4 different chemical formulas here. I want you to copy all of them and circle and label the reactants and the products for each chemical reaction. And an easy way to think of the difference between a reactant and a product is that the reactants are always the stuff present to the left of the arrow in your chemical formula, and your product is always the stuff present to the right of the arrow or after the chemical reaction has happened. Here's another reminder that will help you with the rest of this worksheet. Just to remind you that chemical reactions occur when atoms bond together or break apart. And when this happens, the atoms in the compounds get rearranged. That word there is really key. Things don't get rearranged unless you produce new substances, and new substances don't get produced unless you have rearranged the atoms. In this case of this chemical formula, I have a molecule of CH4, C and 4 H's, plus 2 oxygen atoms. Remember that this right here means O2, so I would draw 2 O's. But this coefficient right here means that I have to draw it 2 times. It means I have 2 molecules of O2. So that's why I drew it once, O2, and twice, O2. This means I have C and O, and this means I have an H2O molecule, but because I have a coefficient, I have 2 H2O molecules. Something that's really important to see here is that all of the atoms are still there. Look, I have 1 C and 1 C in the product. I have 1, 2, 3, 4 O's, 1, 2, 3, 4 oxygen atoms, but they're rearranged and attached to different atoms. The hydrogen atoms were attached to the carbon and the reactants, but now the hydrogen atoms are attached to the oxygen atoms for the product. So since these atoms have been rearranged, I know that a chemical reaction has occurred.